Hey guys, welcome back to another video. I hope you are all doing well and that you're healthy. I don't know, still just a weird time. We're all still taking it one day at a time, just trying to figure it out. So let's go ahead, do some target D notes. This is our last target of KC9. After this, we're just gonna be doing some practice, doing some activities and stuff like that. So here we go. Let's start. So our 9D, it says, distinguish between situations modeled with linear functions and with exponential functions when presented with a real-world problem. So we're kind of looking at the difference between linear and exponential. So let's look at linear functions. So with linear functions, we have a common difference, right? Which means that we are doing addition and subtraction to get from one number to each other. So we've got, our equation is mx plus b for linear functions, right? We've seen that a bunch. So that's, we do addition and subtraction to get from one number to the next. For exponentials, we have a common ratio. So this means we're doing multiplication and division to go from one number to the next. So if we remember our equation, it's a and then the number that we're multiplying or dividing to the x, right? So those are our two functions, the two different equations, and how we can decipher between the two of them. So number one says, identify whether the tables below represents a linear or an exponential function, justify your answer. So table A, we need to decide if it's linear or exponential. So we're going to look at how we're getting from one number to the next number. Well, in this one, we're just adding 2 each time. So when we're adding, that means we are doing linear, right? So our explanation is that we have a common difference of positive 2. So table A is linear. So let's look at table B. Table B, we've got 16, 8, 4, 2, 1. So if we look at this one, we're actually dividing by 2 each time, right? We're cutting each one in half. So because we're doing division, that makes it exponential, right? So our explanation is going to be, we have a common ratio of 1/2, because remember, if we're doing division, we write it as a fraction, so a common ratio of 1/2. So the next one, determine if each table represents a linear function or an exponential function. So this one, we just got 1, 2, 3, 4, 5, easy, right? We're just going up by 1. So it's linear because we are adding. Next one, we're doing 15, 12, 9, 6, 3. So with this one, we're going down by, we're just subtracting 3 to get to the next one. So addition and subtraction, that is still linear. This one we've got 81, 27, 9, 3, 1. So we can tell right off the bat that's not linear, right? Because we're not just adding or subtracting the same thing. With this one, we're actually dividing by 3 each time. So that makes this one exponential. Right, and then the next one we've got 3, 6, 12, 24, 48. So our numbers are getting higher and higher really quickly. So with this one, we're actually multiplying by 2 each time. So again, we have exponential because exponential, right? Because multiplication. So multiplication and division, exponential, addition and subtraction, linear. All right, it says, which situation can be modeled by an exponential function? Number of students attending Wharton West increases by 35 each year. No, because that just means you're doing plus 35 each time, so that doesn't help. Flip phone sales at Verizon are decreasing by 375. No, because that's just subtracting 375 each time. Approximately 12,000 people enter each day. This one, that's not even changing any amount, it's just telling you a number. As x increases by 1, the value of y increases by 6. Again, no, that just means you're going up by 6 each time. Ford F-150 truck sales have been increasing by 3% daily, so yes. So whenever you kind of see a percent, that tells you automatically that that's going to be exponential, because with this one, it's increasing by 3%. So you're going to be multiplying by 1.03 because that's 100% plus 3%. So next one. As part of his biology project, Luis is observing the growth of 2 plants. Plant A had an original height of 5 inches and is growing 1.5 inches per week. Plant B had an original height of 3 inches and its height is increasing by 45% each week. Define the variables and write a function that represents the growth of each plant. So defining the variables, we have the independent variable and the dependent variable. So the independent variable is going to be time, right? Which in this case is your number of weeks. That doesn't look like an E. There we go. And your dependent variable is going to be your height of your plant, which in this case is inches. Okay? Because the height of your plant depends on how long it has been growing, right? So the height depends, right? Height dependent depends on time. So plant A and plant B, we have to write functions. So plant A, so this one's just growing 1.5 inches per week. So that one is going to be linear. Increasing by 45% each week means that this one is going to be exponential, right? So plant A is our linear one, and plant B is our exponential. Right, linear, that's f of x equals mx plus b, and our exponential is f of x equals a b to an exponent of x. So the linear, so it started at 5 inches, so it started at 5 inches, right? So started at 5 inches, original height of 5 inches, and then is growing 1.5 inches per week. So we have 1.5x. So the growing 1.5 inches per week, that is your slope. Okay, so the slope is how much it's changing each time. The b, the y-intercept, is just how much it started. Okay, and then for your exponential, write f of x. And then a is your starting number, so it started at 3, and then it's growing by 45% each week. So you have to do 100% plus 45%, because that's how much it's increasing, right, which gives you 145%, but we have to write that as a decimal, so it's 1.45. So then we have 1.45 to the power of x, right? So if we look at that, initial height of 3 inches, that's the A, and then when it says increasing by 45% each week, increasing by 45%. All right, so number 5, suppose you won a contest at the Berwyn Town Center. For the prize, you start by winning $10, and the town agrees each month to either increase by $75 or increase by 75%. Assume that on month 0 you have $10. Use equations or tables of values to determine which deal you would give you the most money by month 10. So first we're going to write the 2 equations, and then we're going to figure out how much it would be for month 10. So we have $10 at the beginning, and then right, I'm just going to say option 1, option 2. So for option 1, it's just increasing what you had, so that means it is linear. If you're doing a percent, that means it is exponential. So we're using f of x equals mx plus b for situation 1 because we have a linear. So it's going to be f of x, and then the m is how much it's changing by. So it's changing by $75 each time, and it says assume that on month 0 you have $10. So we start at $10. So here's our function for that one. So then we're doing option 2. So option 2 is our exponential. So we have f of x equals a b to the x. So a is how much you started with, so we're using the same 10 that we did before, but for b it says increasing by 75%, right? So that means we have to do 100%, increase it by 75%, which puts us at 175%, but we have to write that as a decimal, so 1.75. So 1.75 to the x. So now for both of these, we have to figure out what it would be at month 10. So we're going to take our function, right, and anywhere that we had an x, we're now plugging in 10 because we want month 10. So 75 times 10 is 750 plus 10 would be $760. So using option 1, you'd have $760 after 10 months. This one, right, we're doing the same concept. We have our f of x. We have our function. And then everywhere we had an x before, we're putting a 10, right? So with this one, we're doing 10 times, but we have to figure out what 1.75 to the 10th power is. So 1.75 to the power of 10, 269.389. Right, so in our calculator, we're just going to take that, do times 10 to get our answer. Boom, 2,693.89. Right, so looking at these two options, I can tell you for a fact which one I would want. I would want to have the one where I end up with almost 3,000 rather than 800. So we want deal number 2 because this is mo money. Okay, so the next one, Jessica collects valuable antiques. She estimated that the value of one of her antiques Y in her collection after X years would be represented by the equation Y equals 400 times 1.25 to the X. Which graph models the following situation? So we can kind of eliminate a little bit, and then that will help us to actually figure out which answer choice is correct. So we do know that this is exponential. So first thing we're going to do is actually eliminate D because this is not exponential. And then we have 1.25 inside the parentheses, so that tells us that we have exponential growth, right? Because that number is 1, so we're like increasing each time. So boom, we're going to eliminate B because that is not growth. So now we're choosing between A and C. So what we want to look at is this 400, because that 400 means that we start, let me zoom in here. That 400 means that we start, that is my dog. I love it. That means we start at 400. So we have to look and see between A and C which one starts at 400. So C starts at 200, A starts at 400. So we actually want A, right? Because right here shows us that we start